All right, welcome to the Ultimate Cambridge Exam Strategy Speedrun. We are completely optimizing your approach today to maximize your marks against the clock. Think of Cambridge AS and A-Level Math 9709 not just as an exam, but as a high-stakes esport, okay? It is a perfectly structured system, and like any system, it can be perfectly optimized. Today, we're tearing down the examiner's blueprint for vector analysis. We are talking magnitude, unit vectors, displacement, and position vectors. Our core objective? To teach you how to optimize your cognitive reading speeds, deploy rapid execution frameworks, and completely eliminate wasted actions. We want you conquering these high-tariff questions well before that time limit hits zero.
So, let's look at the root metrics. Did you know that vectors account for approximately 15% of your total marks in Paper 2? 15%! In a standard Cambridge exam, that represents a massive chunk of your overall grade potential. This is a crucial segment of the map where you absolutely must maintain a high mark velocity. If you get bogged down here, if you start leaking time, your pacing for the entire rest of the paper is totally compromised. You can't just know the math, you have to know the optimal route to execute the math. We're talking about maximizing your marks per minute. We have to identify the time saves and aggressively cut out the time sinks, those secondary, non-essential steps that candidates write out but the examiner isn't even looking for.
We've got a strict run path for this explainer. We're hitting the core principles, locking down the procedural framework, upgrading our evaluation and analytical thinking, and finally dodging the top examiner pitfalls. Let's go.
Okay, phase 1, the core principles. This is where we build the absolute bedrock of our multi-stage vector analysis.
Before things get incredibly complicated, we have to define our sandbox. These 4 vector components, magnitude, unit vectors, displacement, and position vectors, demand rigorous, evidence-based reasoning. In a high-pressure, time-locked exam scenario, your 60-second command word scan is your best friend. You must instantly identify what the question is asking based purely on its verbs. The exact moment you read the command, find the magnitude, your brain needs to instantly snap directly to the Pythagorean framework. Zero hesitation. When you see position vector, you immediately anchor your mental map to the origin. Boom, done. A major time loss happens when candidates confuse a displacement vector with a position vector. That causes an immediate heavy drop in grade potential because they've just chosen the wrong analytical route right off the starting line. It's literally like running the wrong way in a maze. You burn time, and you get 0 points for the effort.
Now, what's really fascinating here is that the syllabus specifically demands that top-tier candidates move way beyond rote memorization. You have to master principles that you can deploy anywhere. Examiners deliberately design high-tariff questions as completely unfamiliar contexts. They are actively testing to see if you have a connected, conceptual understanding. If you just memorize basic textbook examples, you are going to hit massive cognitive overload the very second they throw some weird 3D geometric shape at you that you've literally never seen before. To keep your mark velocity up, you have to maintain clarity by recognizing the underlying vector relationships, completely regardless of the visual disguise. You see straight past the unfamiliar context, extract the relevant data, and instantly plug it right into your pre-established vector framework.
Moving into phase 2, the procedural framework. We are shifting from theory to execution to secure those vital, non-negotiable method marks.
This standardized 5-step sequence brilliantly illustrates what we call the method mark strategy. It proves that examiners award marks for your systematic processing, not just magically arriving at the final result. To really visualize this, let's jump into the co-op challenge arena. Imagine 2 players running this exam. Player 1 is Alex, and player 2 is Sam. Alex hits step 1, deconstructing the question, but gets completely bogged down detailing secondary evidence points. Alex starts writing out basic textbook definitions of vectors before even attempting to solve the problem. That is a massive time sink. Your screen buffer is locking out, and you're wasting time on zero-mark actions. On the flip side, we have Sam. Sam is a ridiculously fast writer. Sam moves at ultra-high speed, but completely skips step 4, executing with clear notation. Sam just throws a highly complex answer onto the page, but triggers immediate marking penalties because the method wasn't shown. Look, the optimal speedrun route is right here. Deconstruct, extract, select, execute, present. You have to balance Alex's accuracy with Sam's speed by rigorously and flawlessly executing this exact 5-step checkpoint system.
And part of that perfect execution? Presentation. It is totally non-negotiable. You must rigorously follow these strict conventions when laying out your mathematical evidence. When you write out long, chaotic, winding blocks of math, you lose the examiner's eye. It's game over. When you scribble numbers without appropriate formats, The examiner literally cannot award you the method mark, even if your brain did the right math. You have to clearly annotate your vectors. If the problem gives you a column vector, write it as a column vector. If you are calculating a unit vector, use the exact proper notation. This strict step-by-step compliance is exactly what guarantees you don't drop a critical easy mark simply because of a sloppy UI on your own exam paper.
Let's hit Phase 3, Evaluation and Analytical Thinking. This is where we upgrade your processor to unlock the highest tier of marks.
Time split check. Okay, before we execute this next top band framework and lock in that A-star grade velocity, you need to optimize your feed. Subscribe to Ace the Exams at Ace the Exams right now and turn on all notifications. No matter if you are running IGCSE, O-levels, AS, or A-levels, this channel is your central tracking hub to outpace the clock and totally beat the examiners. Okay, back to the run. To hit those descriptive, analytical, and evaluative levels, you must run every single vector problem through this precise mental loop. When you hit a structural roadblock mid-calculation, where your evidence drops out of alignment and your mark tracking stalls, you need an optimization template. Even in math, a structured framework like Peel is incredibly effective. Point, evidence, evaluation, link. Point out the specific vector relationship, extract your pure mathematical evidence, evaluate the alternative path, like should I use a geometric or a Cartesian approach here, and finally link it back to make your justified recommendation based strictly on the numbers. This ensures you generate a pristine, high-scoring block of mathematical text every single time.
I absolutely love this quote directly from the Examiner Insights. It tells you exactly, verbatim, what separates a standard student from an elite, top-scoring candidate. Questioning assumptions in vectors often means looking at your newly calculated magnitude or direction and executing a rapid sanity check. Does this vector physically make sense within the context of the 3D space they provided? Top-scoring candidates act like optimization analysts. They constantly consider different perspectives. Maybe they verify a displacement vector by quickly checking the reverse root in their head. And they justify every single micro-decision with clear, heavily annotated mathematical evidence.
Phase 4. Top examiner pitfalls. It's time to locate and patch the performance leaks that are secretly tanking your score.
All right, I'm handing the controls over to you for a live viewer time trial. Let's do a Spot the Performance Leak challenge. I want you to imagine a highly complex Cambridge vector problem about two airplanes flying with specific positional coordinates. A candidate writes down generic equations for a line, calculates everything perfectly, but their final answer just says 5i plus 3j. Where is the leak? Why did they just lose 4 critical method marks? Think about it. All right, I'm handing the controls over to you for a live viewer time trial. Let's do a spot the performance leak challenge. I want you to imagine a highly complex Cambridge vector problem about two airplanes flying with specific positional coordinates. A candidate writes down generic equations for a line, calculates everything perfectly, but their final answer just says 5i plus 3j. Where is the leak? Why did they just lose 4 critical method marks? Think about it.
So, memorize these top 3 mistakes immediately. Safeguarding against these 3 errors alone will directly and efficiently protect your 15% mark allocation. Number 1, answers that are too vague are a massive drain on your time and your marks. Examiners want the specific details. Number 2, forgetting to check format and presentation. This means you did all the hard mathematical labor, you cleared the entire level, but you tripped and fell right before the finish line. And number 3, as we just covered, failing to be specific to the context given. This means you totally misunderstood the examiner's core assessment objective. When you're executing your final 5-minute quality review pass at the end of the exam, scan your paper mercilessly. Are your vectors formatted perfectly? Are your final statements explicitly answering the specific context of the prompt? If yes, you've optimized your run.
Now here is a massive time-save strategy, the visual story method. Under extreme exam pressure, your working memory buffer can become totally overloaded. By encoding complex vector concepts using a visual story, you lock in definitions instantly. Try associating a position vector with a specific visual anchor, like a starting base in a video game. Then see displacement vectors as the exact, mapped-out directional movements your character takes to get to the next objective. You encode the abstract math into a spatial, interactive story. Magnitude simply becomes the raw distance traveled.
Unit vectors become your fundamental single-directional steps. This visual story method prevents your brain from freezing up. It keeps your cognitive processor running at maximum efficiency, ensuring you immediately select the correct analytical framework without burning the clock.
All right, victory screen. Our mark velocity tracker is hitting 100%. To distill today's speedrun, you must enforce these 3 universal optimization rules. Rule 1, the 60-second command word scan. Lock on to the specific requirement immediately. Rule 2, the marks per minute budget allocation. Stick strictly to the procedural framework to perfectly balance accuracy with raw speed. And Rule 3, the final 5-minute quality review pass. Patch those contextual performance leaks before your time expires. Which leaves us with one final, absolutely critical question to ask yourself. Are your vector answers truly context-specific, or are you still bleeding method marks on generic presentations? I want to know where you're getting stuck. Drop a comment below right now sharing which specific Cambridge unit framework you find the hardest to clear under time pressure. We'll tackle it in the next run. Make sure you hit subscribe on Ace the Exams at ace-the-exams, click that notification bell for weekly speedrun tutorials, and keep optimizing. I'll see you in the next masterclass.